Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Danish Izzuddin bin Mustadza, and my emerging technology project entitled Performance Evaluation of Repetition Code in Non-Orthogonal Modulation System for Future Wireless Communication System. Let's get into it. A non-orthogonal signal is introduced due to the incompatibility of the orthogonal signaling system to adapt the excessive use of mobile devices for a future wireless communication system. The usage of the system was proposed due to its ability over increasing the capacity of bandwidth and bandwidth efficiency via massive overlapping of the subcarrier. As you can see from the diagram, the top one is the OFDM, and the bottom one is non-OFDM, which is more compact and more efficient than OFDM. And for regular repetition code, if the given value is 1010, then the repetition parameter is defined as 3, then the code received will be 111.000.111.000, as it's repeated 3 times for each value. And for the irregular repetition code, if the given value is 1010 and defined is 50% of the value will be repeated as much as 3 times, and the other 50% of the value will be repeated as much as 5 times, then the code received will be 111.000.111.100.000. That's such of example for regular repetition code and irregular repetition code. For a problem statement, a non-orthogonal modulation system will lead to a higher interference during the data transmission and reception process. A complex channel coding will lead to increasing processing times and increase the mathematical complexity. And the other one is the OFDM system consumes high bandwidth when transmitting at a higher bit rate. That's the problem statement the project tried to tackle. And for the objectives, the first one is to design a coding for repetition code and irregular repetition code into a non-orthogonal modulation system via exit chart. And the second one is to evaluate and compare the performance between regular and irregular repetition code in order to enhance the efficiency of the wireless communication system via bit error rate and signal to noise ratio. As you can see, this is the exit chart for the regular and irregular repetition code via MMSE graph, exit chart graph. As you can see, this is the modulation is equal to 2, and the yellow one, the yellow line graph represent regular repetition code for modulation equal to 2, and the orange one is represents irregular repetition code modulation is equal to 2. As you can see that the line of graph is nearby to each other because the irregular repetition code set is the 50% of the value repeated thrice, and the other 50% value was repeated 5 times. So it's almost the same. That's why it's nearby to each other when we compare in the exit chart. So for the project complexity, as in flow chart, first we build the coding for RC and IRC before we code for the analyzer. After that, we analyze the matching between MMSE and different repetition parameter, which is via plotting exit graph. Then we check, is it matched or not? If it's not, then we have to analyze it again If it's yes, then we use the chosen repetition code parameter and MMSE to the whole non-OFDM. After that, we analyze for BER and SNR. Then we check again, is it match or not? If it's not, then we have to go back and analyze the matching between MMSE and different repetition parameter again. And if it's matched, then the project could end there. For project significant, very much of it lies on its efficiency. If you look at the enhancement, we can further enhance for future wireless communication system via implementation. Right now, worldwide using OFDM, and non-OFDM is still in experimental state. But the idea is to improve the usage of wireless communication system, which is we can implement it in the future for better and wider efficiency. And as for easier understanding, you could see it this way. Everyone wants faster and exact message sent and received without error. You could look at like that, and that's what the non-OFDM trying to reach. As its complexity, non-OFDM using repetition and irregular repetition code are not as complex as OFDM exists right now. And for marketability, well, wireless communication system is worldwide, and if non-OFDM proven to be stable and more efficient than OFDM, then this whole world gonna change from OFDM to non-OFDM quick. And that's it from me. Thank you.